Our next type of problem to look at for solving Newton's laws are pulley problems. Now in pulley problems, just like in dealing with strings, we're going to deal with what are called physics pulleys. These are superior to any type of regular material type mechanical pulleys that you might find in the mechanical engineering department. And that's because physics pulleys are made of ethereal stuff. These wonderful pulleys are massless. So they're made of stuff that has no mass and frictionless. Real pulleys are not this way. Real pulleys have mass, and that means we have to consider the fact that you're going to have something make that mass accelerate, and also they have friction. Now we'll come back and deal with more realistic type pulleys for like really heavy pulleys that you might have in one of the later chapters when we deal with rotation. But for now, we're going to deal with what are called physics pulleys, and they have this purpose. The only thing that the physics pulley does, if you think about it, is simply take the direction of a force and redirect it. So if you've got some object, like this object, and it's attached by some rope, and then that rope goes into a pulley, and let's assume that there's some thing like that, and then across that pulley is the rope to another block. The purpose of this pulley is simply to redirect the direction of that force. It does nothing else. It doesn't change the tension in the rope. Now, if this pulley had mass, the tension in this rope right here where it touches the pulley would be different than it is there. It would have to be, we're going to find out, to produce what's called a torque, which would be necessary to create this angular acceleration. Those are all concepts we'll cover in a later chapter. But for right now, the only thing this does is that this object would be moving like this, and when it moves like this, it causes that object to move in that direction. It changes the direction of the force and thereby changes the direction of motion of the objects that are attached to it. Alright, so we'll come back and show you how to handle this, because it turns out it's really easy to handle these pulleys if you know what's called the rule of the gun. Other important things to know about pulleys. The string always enters and leaves perpendicular to the pulley. So that means that the force is perpendicular to the radius of the pulley. So if you pull down at a particular point like that on a string, you can be sure that that string makes a right angle with respect to the radius. On the other hand, if you pull this away on the rope, then it will be perpendicular to the radius here. Now how can it do that? Well, what happens is as you start to pull up on the rope, to pull horizontally, the rope will unwind until it gets back to the point right here where it's perpendicular to the radius. That is always the case. So interestingly enough, they can give you all sorts of angles in problems we're going to find out in later chapters, like this angle. And that's great for breaking the vector into components, but later on we're going to need to know this tension, this distance, and the angle between them. And the angle between them is always 90 degrees. That's something I'm front loading in your notes for later in the course. The trick. When working problems like this, we want to use what is called the trick, the rule of the gun. If you have a pulley and two objects are connected with a string across that pulley, what you want to do is draw the free body diagram of one of your masses and choose an axis for that mass. Then draw the second body, free body, but you don't get to arbitrarily put the axis down for that. What you have to do is apply the rule of the gun to get your axis set. And here's the way it works. place your thumb of your right hand along the x-axis and your index finger along, your thumb around the y-axis and your index finger along the x. There isn't actually a choice, but that's the way I do it. Then follow the string over the pulley to the next object. Your thumb and index finger still point in the directions plus y and plus x. And that's how you label your coordinate system. Let me show you this. You have an object, say like, there's my pulley. There's my table. And here's my object. And there's my rope going to my pulley, and then from the pulley to the other object here. So if I draw this one, there's a normal, there's a weight, I call that W1, and there's a tension. And I'm allowed to set my axis any way I want, so I'll set my axis like that. Now, for the second free body diagram, there's the body. The tension is now pulling up, because that's the rope. The weight is pulling down. But when you start to do the axis, you apply the rule of the gun. Now, what the rule of the gun says is that when this thing is your finger, and that is your thumb. And I'll show you this in a video in just a minute. Then you take that and go around here. Now your finger is pointing this away. And your thumb is pointing up. Well, the thumb still points along the y direction, so that is now y. And the finger still points along x, so that's x. Notice that this coordinate system has rotated. What this enables you to do is that as this thing moves 1 unit, say 1 meter in the x direction, this object moves this direction, which is on that we're calling x. So 1 meter in x means 1 meter in x. If you go 1 meter in minus x, then you're going to go 1 meter in minus x. It connects those two sets. If you do this, then there's only one a sub x for both blocks. And there's one acceleration of y for both blocks. If you don't do this, then the acceleration of this block along x is not the same as the acceleration of x in this direction, and you have to have subscripts. These lead to what are known as constituent equations, and lots of books try to teach you that you have to come up with some trick to figure out what these equations are that you need to add. The rule of the gun eliminates all of that. It's an easy trick to make this stuff work out. Okay, here I've got this object. You can see my finger pointing along x, thumb along y. I follow it up to the pulley, over the pulley. My finger now pointing down is the x, and my thumb is the y. This is the rule of the gun. Go along the string to get your new axis.